Okay, so we're going to continue our polynomial unit by refreshing our memory about how to multiply polynomials. So that's our learning target. Okay, so let's start by just taking a monomial times a monomial. And how do we do that? So if you'll recall, x is the same as just x, right? X to the third is really the same as x times x times x. So how many x's do we have? Well, we've got 4. So this is equal to x to the fourth. Now, a shortcut, as you may recall, is I can just take these exponents and add them. So I get x to the fourth power then. Now, that's just a shortcut. Doesn't mean you're adding, you're still multiplying, right? This is still multiplication all the way through, and we got x to the fourth. It's just rather than we have all those and we put them all together, okay? So then if we go through this, what do we get for each of these? So 3x squared times x to the fifth, this would be 3. Remember, this is really a 1, so 1 times 3. And then x squared times x to the fifth is x to the seventh. Add the exponents, right? What's the shortcut? So then this would just be 10x to the third. Okay, this is 1 here, and this is a hidden 1 here, so if that helps you, 1 times 6 is 6. You got x to the first times x to the second, which is x to the third, so 6x to the third. And then here you've got xy times 7x squared. So you might think, okay, well, this is 7. Now the x's are the only thing I can put together. I can't put together the y. So x to the first and x to the second would give me x to the third. And then the y I'm just going to tack on the end. You want to keep your variables in alphabetical order. Okay, and then lastly, this would be negative 9y to the third. Okay, so it's a refresher on how to multiply a monomial times a monomial. Now let's start getting a little bit bigger here. Okay, so our essential question, how do I multiply polynomials? That's really what we're trying to do. Remember, this will come in where we're going to have to combine some like terms. Remember, you can only combine terms that look the same. They have to be x squareds when you're adding or subtracting. That's what we did before. But when we're multiplying, like we just did, you can multiply anything. They don't have to be the same. The only ones you can add exponents, though, will be if they have the same base. Okay? All right. So how do we multiply polynomials? First, you're going to distribute any terms you need to distribute. Okay, and then keeping in mind that property we just talked about, if they have the same base, x and x, then you can add their exponents. Okay, so see that right there. So that's what we're gonna use. Once you've done all your distribution, then you want to look for like terms. And you're going to combine any like terms. Remember, exponents won't change when you combine like terms, just the coefficients. And then lastly, make sure your answer is in standard form. Okay, so let's try it. We're going to start with a monomial times just a polynomial, and this is a monomial times a binomial. So I'm just going to go like, I'm just going to start by doing this, right? Distribute. So I'm going to say 4y squared times 4y to the third. This would be 4, and then y, you're going to add the exponents, so 2 plus 3 is 5. Okay, that's the first term. Now I'm going to do the second term, so I'm going to multiply 4y squared times 3. So 4y squared times 3 would give me 12y squared. Okay, I've distributed. That's step 1. Step 2 is to combine like terms. Are these like terms? No, because one's y to the fifth power and one's y to the second power. And when we're combining or adding, in this case, we can't combine them unless they have the same exponent and same variable. So no. And then lastly, is this in standard form? Yes, it is, right? Highest degree to lowest degree, so we're good. And so that one's done. All right, so now sometimes you're going to see extra variables. And again, you want to keep your variables in alphabetical order. If it helps you to remind you that, okay, I need to remember that this really has a 1 on it, so does this. You might go through and put 1s wherever you see just one of those. Remember, there's a hidden 1. There's also a coefficient of 1 out in the front. If that helps you, don't write it in there if that makes it easier for you. If you don't need to do that and you remember that, just fine. It's up to you. Okay, so really what I need to do is do this first. So 5fg times 1f to the 4th would be 5. 1 times 5, 5 times 1. And then you're going to do with f's and then do the g's. So f to the 1st, f to the 4th would give me f to the 5th. Now I got to do the g. There's only one g here, but nothing here. So I'm just going to have just the 1. Okay, so then now we're going to do 5fg times 2f to the 3rd g. So this would give me 10 f. I've got f to the 1st and f to the 3rd. I can put those together by adding their exponents. And then I got a couple of g's. So g to the 1st, g to the 1st, give me g to the 2nd. Now we're going to do times this, right? Now notice that's a -3. You want to think of that. So I'm going to say 5 times -3 is -15. Now we'll look at the f's. I got f to the 3rd and g to the 3rd. Okay, and then times that last one. So this will be positive 5 f squared g to the 4th. Okay, and now we're going to see if we can combine any like terms. Now they have to be exact same exponent, exact same bases. Notice none of these have the exact same base. They both have this, all have the same variables, but they're all raised to different exponents. So none of those are like terms. Lastly, make sure it's in standard form. Well, the degree of this, remember, this is f has a degree of, or a exponent of 1, g has a, an exponent of 5, and g has an exponent of 1. Put those together, that's 6. This 4 and 2 is also 6. This is also 6, and this is also 6. So greatest to smallest, they're all the same, so you can put them in any order. I'm just going to leave them in the same order they're already at. So is this in standard form? Yeah. Okay, you could rearrange these any way you want since they're all the same. So there would be our answer there. So just be careful when you have two variables. Take your time, and you'll be fine. All right. One of the more common ones is taking a binomial times a binomial. So we're going to still follow the same steps here, but when you do this now, you want to start by, some people use a chart and they go through this. I usually just go this times this, and then this times this. So I'm going to take x times 5x, and then I'm going to do x times 2. So this is going to give me 5x squared, and then x times 2 is 2x. Okay, and then next, I'll just use a different color to make sure we're clear. Then next, you want to take this 3 and distribute it to both terms. Okay, so I'm going to go 3 times 5x is 15x, and then 3 times 2 is 6. Okay, so I've just multiplied or distributed. Now step 2 is to combine like terms. I don't see any other 5x's, so I'm going to keep that the same. 5x squared, sorry. So that one, I don't have any of these right here, but these are like terms here in the middle, so I want to combine those. So I have 2x and a 15x. Remember, when you combine like terms, you're not changing the exponent. Oops. So this should be 17. 2 plus 15 is 17x. Don't change your exponent, though. That's not going to become 17x squared. Only if you're multiplying would you change the exponent there. We're adding now. We're combining those. And then lastly, I have the plus 6, which I can just bring down. And then make sure my answer is in standard form, and we're good. Yep, my answer is in standard form. And that's how we multiply when I've got a binomial times a binomial. Okay, now just getting a little bit bigger with each one here. All right, so now sometimes if you draw the arrows here, you might say, well, it's a little too much going on. So sometimes people don't do the arrows then. They just try to keep it in track of what they're doing. So they're going to do this times all 3 of these. That's where we're going to start. So I'm going to start by saying this times this, which would give me negative 8m to the 3rd. Okay, now we're going to do times the second one here. So watch your signs though. This would be negative 20 and then m squared. Okay, and then times the last one, it would give us positive 6m. Okay, now I'm going to multiply. Now that they've done that, I'm going to go ahead and multiply and do negative 5 times all of these. Like that. Okay, so I'm distributing everything to everything. Okay, so I've got negative 5 times negative 4m squared is going to give me positive 20m squared. Notice that's positive. And then I've got negative 5 times negative 10m is positive 50m. And then negative 5 times 3 would be negative 15. Now notice I'm going to erase this part here. When we did this, we have 2 terms here and 3 terms here. So when we multiplied those, we should get 6 terms to start. Notice that's how many we have here. That's a good check to see if you missed any terms. So I have 6 terms. Now I'm going to combine like terms. So I've distributed. Now you've got to combine like terms. Don't change exponents here. Look for like terms. Work your way down. I'm going to start with my highest degree term and work my way down. So let's see. I see here no other m cubed. So negative 8m cubed. Okay. Now let's do squares. I got negative 20m squared and positive 20m squared. Those cancel out. So I don't have to write, that's 0 m squared or just 0. So those are gone. Then I've got 6m and 50m, which is going to give me 56m. And then lastly, I've got negative 15 here and bring that down. Make sure my answer is in standard form. I'm good. 3, degree 3, then 1 and 0. So yeah, we're good. And that's my answer then. All right, one more. So this is a big one. I've got a trinomial times a trinomial. And in this case, remember this is 3 terms, this is 3 terms. So when I start out, I multiply this, I'm going to get 9 terms. That's a lot. So take your time, watch everything. Here we go. We're going to give this a try. So I'm going to do 2x squared times all 3 of these first, just like this. So 2x squared times 3x squared is 6x to the 4th. 2x squared times negative 4x would give me negative 8x to the 3rd. And then 2x squared times negative 7 would be negative 14x squared. Okay, those are my first 3. All right, now we're going to do negative 3x times all 3 of these. Just like that. Okay, so negative 3x times positive 3x squared gives me negative 9x to the 3rd. Negative 3x times negative 4x is positive 12x squared. Negative 3x times negative 7 is positive 21x. Okay, now we're getting there. Now we're going to do 1 times all of these, right? 1 times this, 1 times that, 1 times this. Since it's 1, it's not really going to change anything right here. So this is 1 times 3x squared is 3x squared. 1 times negative 4x is negative 4x. And 1 times negative 7 is negative 7. 9 terms there, that's a lot, right? Okay, now you need to combine like terms. So start with your highest degree, work your way down, remembering exponents are not going to change, just the coefficients. So I'm going to start with 6x to the 4th. Okay, now we're going to do our, let's do our cubes. Negative 8x cubed, negative 9x cubed, and there are no other ones. So that's negative 8 minus 9 is negative 17x cubed. All right, let's do our squares. We got negative 14x squared plus 12x squared. I got another one over here, plus 3x squared. So negative 14 plus 12 is negative 2. Negative 2 plus 3 is 1x squared, or just x squared. Okay, now we got, let's see, 21x and negative 4x. So that's going to give me positive 17x. Use your calculator if you're not sure. And then lastly, minus 7. Okay, my answer is in standard form. I got highest degree to lowest degree. We're good. And that is how we multiply polynomials. Okay, take your time, watch your exponents, and you'll be fine. All right, this is your assignment. Write it in your planner and then check it off once you're done. Good luck.